So we need to use the definition of a Taylor-Maclaurin series to find the first four non-zero terms of the Taylor series for the given function centered at A. We also need to write the power series using summation notation, and we need to determine the interval of convergence of this series. Well, the Taylor series for a function f of x continuously differentiable at x equals 0 at x equals a is given by f of x equals f of a plus x minus a squared over 2 factorial times I've missed one term. So x minus I over 1 factorial times f prime of a plus x minus a squared over 2 factorial times the second order derivative of f of a plus x minus a cubed over 3 factorial times the third order derivative of f of a, and so on. So here in our case, f of x equals logarithm base 3 of x plus 1 and a equals 0. So let's substitute the values. We will get that f of x equals f of 0 plus x minus 0 over 1 factorial times f prime of 0 plus x minus 0 squared over 2 factorial times the second order derivative of f of 0, and so on. Then this equals logarithm base 3 of x plus 1 plus x over 1 factorial times 1 over x plus 1 multiplied by logarithm of 3 plus x squared over 2 times negative 1 over x plus 1 squared multiplied by logarithm of 3 plus x cubed over 6 times 2 over x plus 1 cubed times logarithm of 3, and so on. If we simplify this, we can rewrite it as logarithm of x plus 1 over logarithm of 3 plus x over x plus 1 times logarithm of 3 minus x squared over 2 times x plus 1 squared times logarithm of 3 plus x cubed over 3 times x plus 1 cubed times logarithm of 3, and so on. So the first four terms of the Taylor's expansion of the given functions are this term. So this is the first term, this is the second term, this is the third term, and this is the fourth term. These are the four terms. Well, now let's do part B. We need to find the power series for the above Taylor's expansion, and it's given by f of x equals the sum from n equals 0 to infinity of x minus a to the power of n over n factorial multiplied by the nth order derivative of f of a. Well, and finally part C, we need to find the interval of convergence. To do so, we will rearrange the series. So f of x equals x over x plus 1 times logarithm of 3 plus x over x plus 1 times logarithm of 3 minus 1 over logarithm of 3 multiplied by x squared over 2 times x plus 1 squared minus x cubed over 3 times x plus 1 cubed plus x to the fourth power over 4 times x plus 1 to the fourth power minus x to the fifth power over 5 times x plus 1 to the fifth power plus x to the sixth power over 6 times x plus 1 to the sixth power, and so on. Then this equals x over x plus 1 times logarithm of 3 plus x over x plus 1 times logarithm of 3 minus 1 over logarithm of 3 times the sum from n equals 2 to infinity of x to the power of n over n times x plus 1 to the power of n times negative 1 to the power of n. So this series will be converging if this term is convergent. So let an be equal negative 1 to the power of n times x to the power of n over n times x plus 1 to the power of n. Let's apply the ratio test. So L equals the limit of the absolute value of an plus 1 over an, where n approaches infinity, and this equals the limit of the absolute value of x to the power of n plus 1 over n plus 1 times x plus 1 to the power of n plus 1 times negative 1 to the power of n plus 1, and this whole thing is divided by x to the power of n over n times x plus 1 to the power of n times negative 1 to the power of n, and n approaches infinity. Then this equals, let's simplify, this equals limit of the absolute value of negative xn over x plus 1 times n plus 1, where n approaches infinity. Then this equals the absolute value of x over x plus 1 multiplied by the limit of the absolute value of 1 over 1 plus 1 over n, where n approaches infinity, and this equals the absolute value of x over x plus 1. So the series is converging if L is less than 1. So that means that x over x plus 1 is less than 1 but bigger than negative 1. So this is true for x. So the fact that x over x plus 1 is less than 1 is true for any real value of x, true for all real x. So now we need to check only that condition that x over x plus 1 is greater than negative 1. We get that x is greater than negative 1 over 2. So that means that the interval of convergence